age of the Earth. There are a lot of theories on how to find out the age of the Earth. I'm going to go through a few of them. I'm going to try and get through this in one video as much as I can, so I'm going to go a little bit fast. But how old is the Earth, and why do we think that? There's a bunch of theories. I want you to know the theory and why it wasn't quite right. So let's start with Aristotle. You don't need to know Aristotle's name, none of the names and dates. Just Aristotle thought the Earth was eternal because it was created by earth, wind, fire, water, and ether, the 5 elements, and the 5 elements are eternal. Therefore, the Earth is eternal. Very philosophically satisfying, but not scientific. Then there was Bishop Ussher, not related to the rapper. Bishop Ussher says the Earth was created in 4004 BC on a Thursday at 9 p.m. He says that because the Bible said Moses was beget by Abraham, who was beget by so-and-so, who was beget by so-and-so, who was beget, and he measured all the begets backwards to the beginning of time, which is Adam and Eve. Well, that's great, but the Bible says man wasn't created first, so what happened before that? It doesn't say. Bishop Ussher couldn't tell us. He told us the day and the time and the year, but he couldn't tell us what happened before that. Was it a week? Was it 4.5 billion years? We don't, according to Bishop Ussher, who knows? It was like a week maybe. But that is all based on the Book of Genesis. Those are the first 2 theories. Third theory, Buffon, I can't remember his first name, it's not on the paper. The Comte de Buffon, he's a count. Took a piece of iron about yay big and heated it to glowing red hot and measured how long it took to cool. And then he said the Earth used to be glowing red hot and it took time to cool. And this is an iron sphere. The Earth is mostly iron, right? No, the Earth is not mostly iron. The core is iron. The inner and outer cores are iron. The mantle's got a lot of iron and magnesium, but surface is mostly silica, and he didn't realize that silica acts like an insulator and slows down the cooling. And so he said the time it took for this much iron to cool, and then he compared the mass of this much iron to the mass of the Earth, which the mass of the Earth you can calculate based on how fast it goes around the sun. You can do the math, it's not that hard. A little bit of, okay, there's a little bit of difficulty to some of the math, but it's not terribly hard. And you can get the mass of the sun. And that will let you tell the different, if they're made of the same material, they should cool at the same rate. But the Earth has an insulator on the surface of it, silica, granitic and basaltic crust. It's insulated it doesn't cool at the same rate as a chunk of iron this big. It just doesn't work that way. Hermann von Helmholtz, you gotta love a good German scientist name. Helmholtz is a great German scientist name. Calculated it would take the sun to condense from a nebula down to the sun's diameter. He figured out how long it would take to condense down to the size of the sun from a nebula size down to the size of the sun. And he said, well, I'm sorry, the Comte de Buffon, he said it was 75,000 years old. The Earth is 75,000 years old. Helmholtz says it's 20 million years old. And then, not terrible, not bad science, just what was before the nebula? And how long has it been since the sun formed? We're missing something. Lord Kelvin, a very, very respected scientist. Lord Kelvin created the Kelvin temperature scale and was very, very good at physics, thermodynamics. He was very well respected, and when he was alive, he was a very well respected scientist. That's rare. Usually scientists aren't respected till after they die and people realize, wait, that guy actually knew what he was talking about. And so Lord Kelvin said the geothermal gradient, the temperature of the Earth, has changed over time. It started at this temperature, it's now at this temperature, and here's a graph showing how long it would take to go from this temperature to this temperature. He was very good at thermodynamics. He was very well respected. He said 20 million years. So the scientific community said, wait, Helmholtz and Kelvin agree. Two scientists using two different types of science agree on the age of the Earth. And for a long time, 20 million years was the age of the Earth. And because two very good scientists doing two different, completely different calculations came up with a number. Let's see. Charles Lyell said it takes a certain amount of time for dirt to build up to a certain height. And he took all the layers of dirt that anybody had ever studied, and he said, okay, well, it's this height, and this height, and this height, and this height. And he added it all up and said, well, the Earth is hundreds of millions of years old. He couldn't come up with better than that. Hundreds of millions. How many hundreds? I don't know. 400 million? 700 million? 5,600 million? We don't know. He wasn't very specific. And so the problem with Kelvin's graph of geothermal gradient graph, I can never remember that word. The problem with Kelvin's geothermal gradient graph is how much heat was lost from the Earth before the crust cooled. See, his was from the crust cooling to solid till now. Well, there was time when the Earth was molten, and therefore a little bit of time missing from his. As far as sediment building up, what about the rock below the sediment? What about the sediment that's been recycled and turned into mantle material and then brought back up as igneous? What about the rock cycle? He missed a few steps there. Hundreds of millions of years was better, but not quite what we needed. Lord Kelvin and Charles Darwin were the basis for Mr. Thomson's age of the Earth, but he said billions of years. Thomson said billions of years, but I don't know how many billions, because in order for Darwin to be right and Kelvin to be right, you have to have billions of years to go from a blue-green algae to blue whales. To go from a single-celled life form all over the planet, only single-celled, blue-green algae, the first life form, to a blue whale, something the size of a blue whale, or even bigger. There's some redwood trees even bigger than blue whales. The biggest life form on the planet are giant sequoias or redwood trees. To go from this incy one to those massive ones, it's billions of years, but I don't know how many billions. That was Thomson's argument. You cannot have evolution from a single cell to multicellular massive life forms. You can't have that in hundreds of millions of years. It takes billions of years if Darwin was right. And of course, Darwin is the most controversial theory in the world right now, still one of the most controversial theories. And so, too much controversy. And what about before life? Before life, we don't have a measuring stick based on this theory. So Thomson, All right, and then John Jolly, he went back a little bit. He said, all right, the oceans were fresh water once. Not a bad assumption at all. Fresh water coming out of volcanoes, steam coming out of volcanoes, comets hitting the Earth, leaving water behind, that all fresh water. Not a bad theory. He said the oceans were once fresh. Now the oceans are salty. I'm going to measure how much salt goes into the ocean every year from every river in the world. And he did. He didn't go to every river himself. He sent someone to every river in the world, got a cup of water from every river, measured the saltiness of every river being deposited into the ocean, and he found out how much salt is being deposited into the ocean every day. And he figured out if the salt in the ocean went from 0 to today, the Earth must be, 150 million years old. Now that's going backwards, because Thomson said billions, for evolution to happen, billions of years are required. And Thomson wasn't wrong. Thomson just didn't know what happened before life, so he was missing a couple billion years of the Earth's history. But Joly, I hope I'm pronouncing it right, J-O-L-Y, Joly, that's not Jolie, it's Jolly. All right, 150 million years, so we lost a few billion years on that one. But what he didn't account for, how long was the ocean fresh? And what about before there were oceans? See, he didn't account for all of that. There's a lot of stuff. There were just a lot of bad assumptions made in these things. Now we take radioactive materials and use radioactive material decay rates to find the age of objects. And we're up to about 4.5 billion years for the oldest object found on the Earth. One of those objects was from the Earth, and one of those objects was from a meteor impact. Actually, two of them are from the Earth, and one's from a meteor impact. And they're all the same age. They're all 4.5 billion years old. So, but let's get back to this thing. Steno's laws, all about strata, all about the layers of rock, said, well, if this layer is this old, and this layer is this old, and this layer is this old, let's just keep going down back in time, and we find the oldest layer. That's the age of the Earth, because the oldest layer of rock is the age of the Earth. But again, great idea, but what about the non-sedimentary layers? What about the layers that don't have life in them? What about the layers that get recycled and destroyed and brought back as igneous later and become new layers on top, and then all the bottom layers get recycled? What about all that? The rock cycle, he didn't understand the rock cycle yet because it was only 1686. Abraham Werner, Neptunism. If you put, it's again with the strata, if you put the rocks in order and you think about, well, okay, where was Noah's flood? It should be right about here. And he found evidence of massive flooding around the world. And he said, okay, well, this must have been Noah's flood. So, and the Bible says it's this old, and the rocks below it go this old, this old, this old, this old, this. And so he came up with a number, but it was based on the Bible again. And so not scientific, that's religion, not science. There's a slight difference between the two. James Hutton, again, unconformities and strata layers and all that. James Hutton, the father of modern geology, the one who actually turned geology into a science, he said, well, there's the geologic record, the layers, that's not the entire history of the Earth. And so there are gaps. And so he talked about there are too many gaps in the rock record. There's missing evidence. There's rock being destroyed, and that evidence is gone now. And so James Hutton, as the father of modern geology, he knew there was something wrong with these theories. And so he said, no, y'all can't get, those numbers are not valid enough. We need a better way. William Smith, not Will Smith, the rapper. There's so many rappers that have named themselves after famous geologists because rappers love geology. William Smith said, well, the maps of the world have changed. If we believe that the maps of the world have changed, we can figure out backwards in time, well, this used to be here, and this used to be here. So he prescribed to Alfred Wegener's theory. He thought Alfred Wegener had a good idea. And so he said, well, if this was here and this was here, how long ago were they there? The problem is he only went back to Pangaea, 256 million years, 225 million years, I apologize, 225 million years. He only went back 225 million years because he didn't know there were other supercontinents before Pangaea. Pangaea could have been the 5th or the 7th, depends on who you ask. And then a couple of other scientists with the fossil record and rock layers, Cuvier and Lyell both worked with fossils and decided that the oldest fossil is the age of the Earth. Unfortunately, what about before life? Fossils are great. To about 600 million years ago, fossils are great till 600 million years ago. But before 600 million years ago, the Precambrian, and then before the Precambrian, the Hadean, they didn't have microfossil testing back then, and so they couldn't see what was in the Precambrian. And then before the Precambrian, the Hadean, there was no life on Earth, so there's no fossil record. All right. Sedgwick and Murchison, I don't know how to say that, said that if you have to look at the rock layers and how they're sorted and where they all came from, great idea, but what about when the Earth was molten and it wasn't rock? Or what about the rocks that were destroyed? And so there's all these different theories for geologic time. I'm going to run out of time. Radiometric dating, the use of radioactive decay to establish a time frame for that material to break down from its parent material down to 50% parent material, 50% daughter material. That is our new method, radiometric decay and radiometric dating. The only kind of dating geologists really do is radiometric dating. That is the one that tells us that the Earth and these zircons are 4.5 to 4.6 billion years old. So radiometric dating says the Earth is 4.6 billion years old. The sun is supposed to be the same age, just a little older, 100,000 years older. The moon is 100,000 years younger than the Earth. And so we're getting, all right, the time is running, oh my God.